think if I recall, most of you preferred to graph. So why don't you graph x to the 4th plus 1 for me? Grab your calculator, plug that in, and tell me what this looks like. It's like a parabola that's kind of been moved up, right? Okay. So your graph looks like this. Even is the same as symmetric to the y-axis. Odd is the same as symmetric to the origin. Which one would this be? Even. If you fold this thing on the y-axis, assuming that my graph is perfect, would it overlap itself? Yeah, if I had drawn that a little bit better, or if you're looking at your calculator, that's a little more obvious, that if I fold it right here on the y-axis, those pieces should overlap, so it's symmetric to the y-axis, which means even. If I said f of x equals 5x cubed minus 3x. Okay, so we can check this on our calculator. We're checking for even or odd, which is really just talking about the symmetry. So you go to your calculator, you plug in the 5x cubed minus 3x. And yeah, it's kind of like a chair. It's got this little hiccup right here. So even means symmetric to the y. If I folded this thing on the y-axis, it would look like this. Does that overlap itself? No, so it's not even. Odd is symmetric to the origin. That means you have to fold over the y and over the x. If I fold twice, would this thing overlap itself? Yes, it would. If you can't tell for sure from your graph, you could always zoom in a little bit and kind of look. The other option, we talked about plugging in negatives. So if you did that, if it's even, when you put in a negative, it gives you the original equation back. If you take a negative to the 4th power, is that positive or negative? So this gives me the same thing back, which means even. Odd was if you put in a negative, you get the exact opposite. Okay, so a negative cubed, would that be positive or negative?
Negative.
So we would get a negative 5x cubed. Negative 3 times negative x is positive 3x. Is that what I started with?
Nope.
No, so it's not even. Is that what I started with times negative 1? Yes, so that's what means it's odd. So there will be one question like this on the quiz, so not a lot of points. What I want is a yes or no, or sorry, even or odd, but you need to justify your work. So if you're looking at a graph, just draw me a little sketch to show me what your graph looks like. If you plugged in the negative, show me that. So it's really like a 2-point question. 1 point for your work and 1 point for telling me the even or odd.
We just have to do either or of those, right?
Yes, either the graph or the plug in the negative. Okay? A related question, sometimes I asked you symmetry, so it's kind of the same thing. If I said, decide if this is symmetric to the x-axis, the y-axis, or the origin. All right, again, we had 2 ways of doing it. We could do it algebraically or by graphing. So if I gave you this one and asked you to do it, do you want to try it algebraic or by graphing? Okay. So to check these symmetries, to check the x-axis, you make the y negative. To check the y-axis, you make the x negative. And how do we check the origin? Okay. So if I wanted to check the x, that means you plug in a negative for your y. If you square a negative, it is, so it gives me back my original, so that means it is symmetric to the x-axis. But you have to check all of these individually. So to check the y, we made our x negative. So if you square a negative, it becomes positive. So that, again, turned back into the original, so it was a yes. And how do we check origin? Both negative, which will be a yes as well. If you preferred to do this by a graph, in order to put it in the calculator, it has to be y equals, so we would have to solve for y here. That means we would need to subtract over the x squared. How do you get rid of a square on your y? And when you do that, you have to do plus and minus. So then what you're doing on your calculator you are going to have to enter two separate things for your y. So your first one would be a positive square root of 4 minus x squared. And the second thing is a negative square root of 4 minus x squared. So then if I look at that graph, we are getting this. So we can see if I fold that over the x-axis, does it overlap itself? Yes. If I fold it over the y, does it overlap itself? Yes. And if I fold both times, does it overlap? Yes.
My calculator's not working. Thank you.
All right. Do we need to do another one of these? Okay. One more.
Which way do you think so?
It's kind of a toss-up. You know, if you don't mind solving for y, the graph is pretty easy to look at.
Yeah.
The algebraic, it's not that much work to plug in negatives, so as long as you make sure you put it in parentheses and apply your power, it doesn't matter. So if I said, like, y squared equals 3 minus x. If I wanted to solve that for y to graph it, what would you do?
Get y by itself.
So to get rid of a square, you would square root. And when you add a square root, you have to do plus and minus. So if I graph that one, I'd have to do two separate y's again. The first one would be just the square root of 3 minus x. Second one would be a negative square root of 3 minus x. So then if I look at this one, if I flip this over the x-axis, does it overlap itself? Yes. What about the y? No. What about the origin? No. So this one is symmetric to the x-axis only. Okay, so we've talked about symmetry. That will be 2 questions on your test. One question will be like the first one. I ask even or odd. One question like this. X-axis, y-axis, or origin. Both of those you need to show me work somehow. If you're drawing a graph, then just draw me a quick sketch so I know where your answer is coming from. If you're plugging in the negative, show me that work. Is that okay for everybody? Section 3 or 2.1 was when we had the parent functions. So we have reviewed those a lot, and we had like a handout in class one day where we talked through some questions about those. So there was a picture kind of like this, and I might say, okay, which of these is the absolute value function? G. Okay, what is the domain? Negative infinity, positive infinity. What is the range?
0 to
Right. Bracket 0 to infinity. If I asked you where this graph was decreasing, negative infinity to 0. Okay. If I said which one is x cubed? X to the third. A. What's the be, when, is that increasing, decreasing, or constant?
Increasing.
Increasing from negative infinity to positive infinity. Which of these isn't a function?
B.
C.
Or yeah.
Yeah. To not be a function, it has to fail the vertical line test. So C isn't a function. We talked about the equation of that one when we did it. We know it's kind of like a parabola flipped on its side. And the equation of the parabola is y equals x squared. So what do you think the sideways parabola is? It's basically takes that square and puts it on the y instead. We graphed that one in our notes, and then it also came up when we did this little activity in class talking about not a function. So basically to turn it on its side, it just put the square on the y instead of the x. What would be the domain of that one?
0 to positive.
Bracket 0 to positive infinity. Okay. And then we did all of our transformation stuff. That's what we reviewed yesterday. Do we need to talk about any of that? Do we need to practice the stretching or shrinking real quick?
Yeah.
Okay, we'll do one of those and then you guys can do your quiz.
There's gonna be these on there too, right?
There could be. I just recommend drawing a graph and applying a point if you
Yeah.
need to and moving it. So let's say I gave you what are you doing? Okay, what's our parent function?
Line.
Yeah, the square root. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Alright. What will the 4 do? It's outside, so it's y, does what it says. So vertical stretch. And the minus 2? So, vertical stretch. What this means is you multiply your y by 4. Outside is y, it does what it says. So, here my y is 0 times 4 is still 0. And then write 2. Okay, this one has a y value of 1. So, times 4 would be 4. And then write 2. Okay, here a y value is 2 times 4 would be 8, and then write 2. So we get something like that. When in doubt, especially on stretching and shrinking, if you are struggling, make a T-chart if you need to. Plug in some numbers and see what you get out. You know it moves right 2, so you at least know if all you did was move your graph right 2. You know it would look something like this, right? So you could plug in x equals 2, 4, and 6 and see what we get out. If you put in a 2, you get 4 times the square root of 0, which is 0. If you put in a, that shouldn't be 4, 3. Put in a 3, you get the square root of 1 times 4 is 4. You put in a 6, you get 4 times the square root of 4, which is 8. So you can double check yourself there and see where your points are.